Hello everybody, welcome to Unit 7, where we're going to be learning about classes and objects. And we're going to start our discussion by looking at Chapter 17, which covers class basics. Specifically, we're going to be covering subsections 1 through 9 of the Runestone textbook. Now, up to this point throughout our learning adventure, we've been mostly focusing on procedural programming. And this is where we put the focus on writing functions, where the code is executed sequentially. But many software programs are written in what's known as using object-oriented programming, also known as OOP or OOP. And the focus on this is creating objects. And we're going to talk about what objects are as we move along. In OOP, we say that objects are the active agent. This is different from procedural programming or functional programming where functions are the main thing that we are focused on. Now, objects have methods, which are basically just functions that belong to the object, whereas functions exist by themselves. Okay? So to be a little bit more clear, methods are just functions that are attached to a particular object, where the name function refers to a block of code that can be executed, but it's not attached to a particular object. So, as an example, in the past, to draw a square, we would have a function to draw a square that looks like this. Okay? And with this function, we pass in our turtle t and a size sz that is going to be used to make the turtle. You might not have noticed that we have been using methods that belong to objects all along, right? So here you can see that we have our turtle t, and we are calling the forward, what we'd previously called a function. It's actually a method called forward where we pass in a size. So this forward method belongs to the turtle class. And same thing with left here. So left is a method that belongs to the turtle class. Draw square is a standalone function that doesn't belong to any particular object. So what are some of the benefits of using object-oriented programming? Why do some programmers use it instead of procedural or functional programming? Well, for one, it models real life. And it can be easier to think about concrete things that have their own attributes and behaviors than thinking about them as some parameter to pass into a function. It also allows for mental chunking, meaning that it's easier to associate things to other things, right? So we have attributes and functions that belong to something else, right? It also makes code easier to maintain. It's easy to find where something is because it's already associated with a particular file. It also supports reusability because it's easy to use objects throughout your code and to extend them through inheritance. And we're going to talk about that. Data hiding and abstraction adds to your code security. You're not able to manipulate things because all of the attributes are protected within the object, and you can only access them through methods that the author of the class has specified. And there's a lot of other reasons too. It's important to note and to realize that every single value in Python is in fact an object. And as I've stated previously, an object is data and behaviors that are associated that belong to a particular class. So here you can see that an object is its data and its behaviors. And we also say that it's its state and methods. Okay? You can use those terms interchangeably. And the state is basically the current state of the object. It's what the object knows about itself. We're not talking about geographic states. We're talking about logical states. Methods are the actions that an object can perform, or the behaviors. So, for example, take the turtle class. It knows its position, its x-coordinate, its y-coordinate, its heading, and its the distance that it's traveled to some point. We can also perform actions on the turtle, or methods. We can go forward, we can go backward, left or right, we can go to a different point, we can draw a circle, and all of those things that we've used throughout the class already. Those are all methods that we are performing with a turtle object. We cannot call these methods by themselves. They have to belong to a turtle object in order to be invoked. You might have noticed that I've been using the words class and object somewhat interchangeably, and to be honest, fairly incorrectly. There is a distinction between a class and an object, and it is important to understand. A class is a description for a set of objects. Okay? It is what defines what the objects are. You can think of this as like a blueprint, where we say an object is an instance of a class, much like how a building is constructed from a blueprint. As we've seen, there's plenty of objects that already exist, plenty of classes, that already exist within Python. And we create objects based off of those classes. But it begs the question, how do we make our own classes? Well, first, you have to use the class definition. In this case, I'm making a class pet. And you can see here that I'm giving it a comment to tell you what it is, right? So the definition consists of the Python class keyword, the name that we are giving to our class, and our docstring. And we can put class definitions anywhere in a program, but typically we put them up at the top, at the beginning of the program, or we must put them in their own file. And they've got to be declared before they're used, because remember, Python is interpreted line by line. The next step in the process is to define an initializer method. And we also call these constructors. So here you can see we have our initializer method, which is double underscore init double underscore, and then we pass in a variable name. And by convention, we use the word self. This really can be anything, but you're never going to see anything but self used here. Okay. Now this double underscore method, this is a special class of methods within Python that are known as dunder methods. And that's short for double underscore. Okay, so it's a double underscore method or a dunder method. And these are unique in Python, and there's certain key ones that we will define that have special meanings. Okay, but for right now, the first one that you need to be familiar with is the init or initialize. The self variable right here that we pass in refers to the object that this init method belongs to. So when we create a new pet, this is going to initialize that pet. So here we have our self.name is defaulted to Spot, and our self.type is initialized to dog. And this method is called automatically whenever we create a new object of the class. And by defining an initializer method, it allows us to give our data or state to the object. Right? Remember, we talked about objects being state and behaviors, or data and methods. Well, this is the data that belongs to our pet object. So let's go ahead and create a new class. Okay, so we've used the pet class, and we're going to see it in numerous examples already. But let's just, for the sake of variety, let's go ahead and just create another one, another pedagogical example here. We're going to do a class shape, right? So, or we'll do square. So we're going to go ahead and start off with our docstring, right? I'll go ahead and just paste that in there so we're not wasting a bunch of time watching me type, okay? And then we're going to start off with our keyword class, and we're actually going to call this one square, okay? And then we're going to give it our colon, and we're going to give it our docstring, so give it triple quote, class representing a square. Now we've got to define our dunder method, our init method. So we're going to define, and we're going to do double underscore init. And you can see with Visual Studio Code, it will automatically pop up some of the things. Now, this right here is type hinting. This is not necessary, and if you use Visual Studio Code with Pylint, it will automatically put that in. We can get rid of it. It just helps you when you're using the class later on. It tells you what type of things will be returned from a method. Okay, but we don't need that right now. And what we want to do is give a docstring to our method and says creates a new square, right? All right. And then we're just going to use self, and here we're going to say let's give it a length, right? And we can default it to a certain size, right? 5. Once we have done this, we have created a class. We haven't created an object yet, we've created a class. So let's go ahead and use our class within this file, okay? So we're going to say, I want to create a new square, and we're just going to call it my square, right? And we're going to call the initializer function by calling square with parentheses, okay? This is called instantiating an object, okay? We are calling the constructor method of the square class, and that's going to give us a square object. So in this case, when we put in these double parentheses like this, what it's actually doing, it's actually calling this init method, creating an attribute called length, and giving that property or that attribute a value of 5. And we can test that out. We can say, I want to print out my square dot length, right? And so this will print out, what do you think it's going to print out? Well, it's going to print out 5. And you can see that right there. Now, what happens if we don't use the self variable in our function? Say we get rid of that, right? If I go to run this, it's going to say, well, number one, that it's supposed to take an argument. Okay, so we could call this x. We could call this x right there. And then it's expecting it to be there. But see, we get this attribute error saying square has no object attribute length. Okay? Now, if we set this x.length, you can see that it's going to actually work. So this variable right here, what it's called doesn't matter, but we always use self by convention. And this is what attaches this attribute to this object. So if you don't have self here and here, this length property, if we get rid of this, length only exists inside of this method. I can create a variable called temp and set it equal to 5, or set it equal to 4, let's say, and we can say length is equal to 5 plus temp. Okay, and that'll work, except for length doesn't belong to anything, so that would go away as soon as we exit the initializer method. So now we can do this, and if we run it, we're going to see that our length is equal to 9. Okay, so you have to use the self variable, and you have to call the attribute with the dot like this. Now, what happens if we create 2 pets? So here you can see that we have our pet class. We're returning to our pet class, and you can see we have my pet 1 and my pet 2. We use the same code to instantiate a new object, and if we print out both of these 2 things as names, you will see that, of course, they are both called Spot. Well, that doesn't do us really any good if every object we create has the same attribute values, right? So what can we do about that? Well, once we have the objects created, we can assign new values to their attributes. Remember, the ones that we had before were just default values. So here we can assign a new name to pet 2, and we can also assign a new type. And so now it's a cat and its name is Furball. And if we print it out, you'll see that they have, in fact, different values. You'll also notice that here I'm using a different way to format my output string. As I've been going through some of my older code, I've been replacing some of my strings with F strings, and some of them I haven't bothered to clean this up because this is just a screenshot and not actually cut from code. So just if you see differences between an F up here and none of this format stuff, that's just because I'm slowly modifying my code to be using the new F string formats that Python has instituted. What if we don't want every object that we create to have the same values? What if we don't want to have to go in and assign new values to the default values? Well, we can create our constructor in a way that allows us to pass in values so that way they're automatically set when we create the new object. So here you can see we've modified this where we are passing in additional parameters. Okay, we're saying that there's going to be a variable called name and its default value is none. And we're also changing type to kind because type is a keyword and we can't use it as an attribute like this. So we are passing in name and we're changing our attribute to kind and we're setting the default value to none, right? Then what we do is we still have our self.name and our self.kind, and we are going to assign the value to that of whatever was passed in, or none if nothing was specified. And likewise with kind. This kind right here corresponds to the value that gets passed in when the object is constructed. We can also call additional functions and do different things in our constructor or our initializer. Here we are printing out the values that we passed in, and here you can see we're creating a new pet called myPet, where we're passing in the values Chirpy and Sparrow. Chirpy will get assigned to the name variable, and Sparrow will get assigned to the kind value. And then when the object is created, that name will get assigned to the objects.name property, and the kind will get assigned to the objects.kind property. And it will then call print with those values, and so you'll get this output. Let's go ahead and modify our square class to show these changes. So here we're going to extend this and we're going to say, you know what, we want a new property called size, and we're going to set its default value to 5. In fact, we don't want size. Yeah, let's change this to size because length has a special meaning for strings, so I don't want to confuse that, right? We can get rid of temp, you're gone, or clean up our indenting here, and we're going to say self.size is now equal to size. And then we also want to make our constructor automatically print out something when we've created one. Okay, so let's go ahead and do that. So here we're just going to call print, and let's do this with an F string. F string, my size has set to, and we're going to pass in self.size. Okay. Now we can get rid of this print function down here, and we're all set. So now when we run this, what's going to happen is it's going to default to the value of 5, and you can see that we got this printout right here. Okay. What if we want to change the size of our square? Well, we'll run it again and we'll pass in a new value. We'll say it's 15. Okay. There you go. Now you can see that its size has been set to 15 because 15 is passed into size, so it overrides this 5 right here, and that gets assigned to the actual object's size attribute. Now note, we could change this up a little bit if we wanted to. Sometimes in some style guides, some companies, they like these variables to be different, right? So that way you can tell which one's which. So here we're saying underscore size, and is different from this size, and it makes it a little bit more concrete. Okay, or they might say, let's just do SZ, right, and SZ here. Get rid of the underscore and save it. So now this attribute is SZ, and our actual property is size. All right. So just want to kind of clarify that a little bit. Giving methods to our objects make them much more dynamic. They are no longer just containers that store information. Okay? And like I said previously, functions that we add to our classes are called methods, and they are specific to the class that they belong to. And as a general rule, they only work on the objects that have been instantiated. Now, there's a special class of methods called static methods that we're not going to get into, but you'll get into it in your Java class. But for now, we're going to assume that the methods that we create only work with the objects that have been instantiated. So let's take a look at how we add new methods to our objects or to our classes to make the classes much more dynamic. Here you can see with our pet class, we've added two new methods called getName and getType. And these are special methods that are known as getters or accessors. And accessors or getters belong to a special class of methods, and we refer to them as getters and setters. So we have accessors or getters, and we also have mutators, which are the setters. Okay? Getters retrieve the object values, and setters modify the object attribute values. And here's how you can see how they're being used. Okay? Now typically getters and setters are often used in programming languages to support encapsulation. Okay, what that means is it allows us to kind of hide our attributes and only make them accessible through these particular methods that we are defining. And what this allows us to do is add, boundary checks and make sure that certain things are set up right, so we can't modify their values to be something that doesn't make sense, right? So for example, if we had a square object, our setter might not allow us to put in a negative number because it wouldn't make sense for its size to be negative, right? So that's just an example. Now, Python doesn't necessarily have access modifiers that allow us to hide attributes the way that other programming languages like Java and C++ do. In those languages, we can declare different attributes to be public or private using a keyword public or private. The way we have to do it with Python is we have to use these double underscores in front of the name. And this is a process that's called namespace mangling, so I don't want to get into that. But basically what this does, when we use the double underscore in front of the name here, this tells the Python interpreter that this is a private variable and it's not to be exposed to users of the program. Okay? If we want to actually access these or modify them, we have to use our methods here to get them, right? So here is a public method called getName, and here's a public method called setName. And here you can see we're passing in new name, and we're setting our self.underscore new name to what we passed in. When we go to use this in our program, you have to use the getName method to actually get our attribute. Let's go ahead and modify our square class to take into account these things that we've just learned about. So here we want to say, you know what, we want size to be a private method, right? So here you can see that we are modifying size to use the double underscore, right? And this piloting is just saying, hey, this hasn't been used. Notice here that we now have to change this, right? So if we were to run this, our program would still work just fine because we are accessing the size attribute within our initializer. Okay, so it's still working just fine down here. If we try to access my square, instead we try to say, let's comment out this print line, and if we try to call print, and let's just do my square and just say, well, I know there's a double underscore size. Okay, if we try running this, look what happens. It says attribute error. Square has no attribute underscore size. Well, it does. We created it. Okay, so that's how it's hidden. If we want to get this attribute, we have to create a getter. So let's create a getter. Define get size, right? And we have to pass in the self, and we're going to give it a, excuse my mangling here, returns size property. Okay? And then we're just going to return self dot double underscore size. Okay? Bring this guy back here. Now, if we want to print this size property, all we have to do is call get size. And when we run it, now our code is magically working, and you can see that it's printing out the value that we wanted. All right. Now, what if we want to modify the size of our size property? Well, then we need to create a setter function. So we're going to call it set size, right? And of course, we're passing in self, not slef. Okay. And this is going to set the size property. And let's give it an extra thing right there. All right. Now, one of the things that we want to do is we need to be able to pass in a value, right? So we're going to say, we're going to call it new size. And we're going to say self dot underscore size is equal to new size. But now remember, one of the things that I said was that we want to make this more robust. Part of the encapsulation process is making sure that we can't mess up our object in a way that doesn't make sense. So since this is representing a tangible thing, it's representing a square, I want to make sure that our sizes cannot be less than 0. So let's add some conditional logic into this and say if new size is less than or equal to 0, we'll say it's got to be a greater than 0, right? If it's less than or equal to 0, go ahead and set new size equal to 5. And print size must be greater than 0, setting to 5. Okay? Now, what's going to happen is it's going to come in and it's going to check to see that new size is greater than 0. And if it isn't greater than 0, we're going to initialize it and print this out. Otherwise, once we do that, it's going to go ahead and print, or it's going to set our size variable to whatever we passed in, or to our new value 5. Okay, so let's go ahead and test this out. Let's go ahead and try to run this with a -5 and see what happens. Oh, didn't work. Why not? Because we didn't call the set size function. All we did was change the default, right? So we'll give it the default, and then we'll say default mysquare.setSize, and then we'll pass in the -5. And now we run it. And you can see that it called our getter, size must be greater than 0, setting size to 5, and then it printed out the get size from right here. Okay, so it worked. If we make this 20 and run it, you can see that it set it to 20, right? Okay. In addition to passing values in as attributes into methods that belong to objects, we can pass objects themselves into methods and functions. So here we have a print pet function that we are passing in a pet object to the function. Okay? And you can see here we're passing in pet, and then it's going to print out the pet's name and the pet type, and here you can see the results right here. Right? And this, we've been doing this all along with the turtle class when we've written our own functions and we passed in a turtle to do something. We can also create a special method that allows us to tell the print function how it should print out our objects when we pass it in. And we do that with a special method called the string method, which is a dunder method, as you can see by the double underscore. So we define our double underscore string method, and we pass in a reference to ourselves, and we return whatever string we want printed when it is passed into a print method. So here you can see we're creating a pet called, my pet, and we're initializing it with Chirpy and Sparrow, and then we call print and we pass in our pet object. What do you think is going to happen? Well, it's going to print out exactly what we told it to, which is Chirpy is a sparrow. We can also return objects from methods and functions. So here you can see that we are modifying our set name and our set type, which really should be kind. I should have fixed that. Just now realized it. That's okay. But we are returning a reference to ourself when we are done with the method. What does this allow us to do? Well, it allows us to engage in what's called method call chaining, where we can call ourselves, we can call a method off of another method. Because when we call set name and we're passing in FIDO, when we call this method right here, it's returning a reference to itself, which in effect makes this whole statement right here a object itself, because we're returning ourselves. So this now, in between these red brackets, once we call this method, becomes my pet. And so then we're calling set type on my pet, just like we call, or set type, just like we called set name on my pet. And you don't really have to worry about this too much now. This is just an example of how you can use the ability to return objects in a way that's meaningful. And you'll see this in a lot of web programming where you have to set a bunch of attributes for a particular element. And so they'll have an element and they'll use method call chaining to set 10 different attributes all in a row just to make the code look cleaner and easier to maintain. You'll learn more about this in your Java programming class, so you don't have to worry about setting your assignments up to do this. As a final activity, let's go ahead and modify our set size method to return a reference to ourself, so that way we can just call print off of whatever we do. So all we got to do is just return self. Now we can still call set size independently like this, which will print out nothing. So let's actually change this. We're going to say we're going to make this -5, right? And that's going to force us to print out this thing right here. But then we can also call print, and we can call mysquare.getSize. Let's change this to set, and we're going to change it back to 123, right? So now what's going to happen is we're going to create our square, and we're going to set the size to -5, which is going to come into here, and it's going to print this out because it can't have a negative number. And then we're going to call print, and then we're going to set the size to 123, which is going to set the size to 123, then return a reference to itself, which because of our, we haven't created a string method yet. Well, let's do that. Define _str string. We're going to pass in our reference to self, right? And we are going to print our square object, right? And then we're just going to return, because remember, we're not printing, we're returning a string. What do we want to say? We'll say our square has a size of brackets, and then we're just going to say self dot, what are we returning? Size. That's right. Okay. So now when we run this, you can see that we set our, something didn't work. Why didn't that work? Oh, because we didn't make this an F string. Forgot my little F right there. All right, let's run it again. Let's clear this and run it again. Okay, so here you can see we printed out our line when we fixed our error, and then here you can see that we called our string function off of our return self in here. Very confusing, I know, but it makes logical sense if you do a trace of the program. So let's do a trace of the program. Let's put a breakpoint here, run it in debug mode. Go ahead and we'll clear this out, and we'll go ahead and run it. We're going to stop here, right? We haven't created this MySquare object yet, so we're going to go ahead and just step over that. Okay, so now we have our square object. We can get rid of, let's go ahead and minimize these. Right, so now you can see that we have my square object, and you can see that we have access to all of the variables and functions that it has, right? So function variables, right? We have a get size and set size, and you can also see the special variables, right? Some of which we have redefined and some of them we haven't. We have overridden the string method to give us a string when we call it with print. All right, so at this point, our square has a size of 5 because that's our default size as specified right here. Well, let's continue on with our program and see what happens. Let's step into set size. Well, we step into set size and we're evaluating if it's less than 0. It is, so we set our new size to 5. So you can see new size being set to 5. And then we print it out and we set our self._size to the new size value, right? Which you're not going to see here because it should be in the global. If we come up here to my square, you can now see square_size is 5, which is what we want. Now we're jumping down to here, right, and we're going to step into that. Oh, we stepped over it. That's what I meant. We're doing this again. Okay. All right, and now it's printing it out. You can see that we are calling our string method because that's what was called from print. And then boom, we're done. Okay, so you can, if you run the debugger, you can see how the program is jumping around. I highly encourage you to make your own class and play around with these dunder methods and figure out how to return references to yourself and also pass your object around in code. One thing that I really didn't show is you can also create additional methods that just have utility for your class. So in this case, I want to define a method called getArea, which we want to, since it's a square, right, we want to return our area. Returns area of our square. And in this case, we're simply going to return, right, our self _size squared, right? Because the area of a square is that. Now, let's go ahead and use that, right? So here, we set our size to 123. So let's go ahead and print my, let's fix this. Let's put an F string there. My area is equal to, and we're going to go ahead and call my square dot get area, and let's see if this works. And we can go ahead and just run this as normal. We don't need to run it in debug mode, and we can even, no, we want to leave that. So bada boom, bada bing, you see that our area function works, and we get our area of 15,129, which is 123 squared. Okay.